Elixirs and Gleamers. I have an announcement to make. This is the announcement of a new library and tool for the Phoenix framework. This is ElectricSQL. Now for this presentation, I don't want you to put your phones on silent. So everyone take their phone out and take it off silent and make sure that you're connected to the Wi-Fi. This is part of the demonstration. And if everything goes well, then, well, as you do this, ElectricSQL has, so what does this new tool give us? This new tool gives us the idea of local first data with simple and reliable interface and so-called a tool to shape the future. So if, I think everyone looks about ready, so he gave you, well, first he designed this tool for you, thinking about what the Phoenix community and the Elixir community needs. Then he made it for himself, and now, today, he is giving it back to you. So, without further ado, this is James Arthur. Take it away.
Thanks very much. 2025 started for me not with a bang, but with a bug. So I was in Lisbon with the family, my wife and 2 kids, and we'd had quite a nice New Year's Eve out. So we'd been to a restaurant, and they do kind of special New Year's Eve menus. And the one that we went into, it turned out that you got free unlimited wine. So we got a bit tipsy. We were kind of running around the streets of Lisbon with the kids, kind of having fun. And we went home just around midnight. And then we woke up the next morning, and we had booked to go to the New Year's Day concert. There's like a sort of famous one in Vienna where they play like Strauss and the kind of Danube waltz and things. And this was like a kind of version of it in Lisbon. And so we sort of dragged ourselves out of bed early and kind of a bit fuzzy-headed. And we were just heading out to the concert when I made a mistake. Which is, so being a startup founder, I just checked my messages just on the way out. And what I found on there was that one of our biggest users had been down all New Year's Eve. So he was in the US, so whilst I'd been sleeping, he spent 5 hours trying to debug a production real-time product that he'd just built, which was running on our stack. And basically it hit a bug that he couldn't fix. And so what it turned out, we sort of jumped on, we sort of realized pretty quickly that it was a regression that we had pushed that then meant when he had a transaction ID wraparound, the code didn't handle it. And so we got a fix kind of together fairly quickly, but also we were like, okay, we need to verify the fix before we push this stuff into his production systems. And then you're going to go, okay, well, how do you create a database that's in a state with transaction ID wraparound? And you do the napkin math, and it's like, even if you have the biggest machine with 32 cores and a super fast SSD, it takes you a week to like hammer it with transactions to get like 2 billion transactions in the database. So there's 4 of us online, we're kind of scrambling, and eventually you kind of go, okay, we have to patch the C code, and you find an extension that does it, and we push the fix, right? But the moral of the story is that, so that is us running sync in production as a company that specializes in it. And basically rolling sync and running sync is hard. It's not the kind of thing that you want to do yourself as part of your application development. So that's not even, for example, it's not even the hardest bug that we've had this year. We had another one, which is that we had another customer who was doing quite high throughput, and just very occasionally in their streams, we serve HTTP and JSON, there were just stray commas appearing. And it was totally weird because this stuff was just coming out of a log on disk, and there were no stray commas in the log, and we were just serving it. And you're like, how the hell are these commas? And it's totally impossible to replicate because anything like all our tests, all our stuff, there are no commas. But every now and then their production site is hitting the issue. So in the end, like, it was a real Heisenberg. We put in a whole bunch of time on it, and it turned out to be a race condition with building some car lists in the way that we were reading from a disk that was triggered under certain circumstances. And so again, it's like, you know, these things are kind of pretty kind of silly bugs when you kind of figure out what they are, but they're just the kind of difference between when you're running a sync system and you're trying to make sure that actually the messages arrive and it doesn't break, doing that reliably in production is really hard. And there's a whole bunch of engineering into that compared to, for example, building a sync system with like real-time primitives and it just sort of works and it kind of demos well. So why does this matter, right? Why am I talking about this? Well, it's because it's becoming clear that sync is a really important way, if not the best way, of building modern software. You have all the kind of family of systems like Figma and Miro and Canva, et cetera. These products are built on sync, and it's key to being able to deliver the kind of quality of user experience that they do, which is key to their growth as products. It's why people are using them. You famously have Linear, for example. If you think of project management tools and you think back to like Jira and kind of like the previous thing you're there, you're just waiting for kind of page requests, it's kind of hell on earth. And like Linear is used by like something crazy like 75% of kind of all startup companies, and it's captured a huge part of the market because they did all this very cool engineering to build the product on sync. They sync in the local data, and then the local application code doesn't have to go over the network. You take the network off the interaction path. It's key to building this kind of high-quality modern software. And it's not just in app development. You have other domains. So for example, in like data applications, data analytics, you have this concept where client devices like desktops, phones, what you're running the browser on, are just getting more and more capable. And the ability to sync a working set out of some big data system to be able to then do analytics locally instead of sending queries back to a server to do it, is just transforming the type of workloads that people are building in data analytics. This is like a kind of small data conference here in SF that Mother Duck organized, which brought together a whole bunch of interesting companies that were kind of doing that kind of pattern. And then you have the AI stuff, right, that we're all using and everybody is now kind of building applications for. And AI systems, like if you want to do low latency inference, you do not want the network on the path to go and get the data. So actually, AI agents are local first clients. And as increasingly more and more software is being built with AI capabilities into it, this ability to sync data locally for those systems to work with is just the key. It's just how these systems are going to be built. And so this is a video from a conference we organized last year. And it's just a sense there's a bit of a movement kind of around this stuff. This is like the local first software movement, and there's a kind of sync movement. And just increasingly developers are getting interested in these patterns. And this is a guy, Jack McCloy. He's a very experienced engineering manager, VP engineering. He was at Amplitude. He's at Snowflake now. And he was talking from his perspective of like running a very large, mainly sort of front-end engineering teams in those products, that he sees the transformation in this sort of state transfer layer as equal to the transformation that happened moving from like jQuery into React or kind of declarative DOM stuff. And in a way, all the sort of developments in front-end tech have slightly exhausted the value that comes out of sort of switching to better reactivity or state management patterns in the client. And so the new frontier is to go, okay, now let's look at what we can do across the network and the kind of state transfer piece. So of course, in the Elixir community, like Jose Valim, Chris McCord, lots of people involved kind of see this trend. And therefore, it's very strategic to understand how does Elixir fit into the way that software is going to be built in the future. And I mean, as we know, Phoenix has just always had a really rich array of state transfer options, right? It started with like APIs and forms, and then you had Absinthe as a really good early GraphQL library. So Elixir was a great choice for building GraphQL applications. And then of course we've had LiveView, which has sort of pioneered this sort of hotwire model. And then within Phoenix you have primitives like PubSub and channels and sockets, and these things are really, really good primitives for building real-time applications in the framework. And so if you look at, say, LiveView, for example, LiveView does this piece of like keeping the front end in sync with the data that you have in the back end. But the kind of missing piece with that is it doesn't do the piece of keeping the back end in sync with the database. And so whilst Phoenix has very good real-time kind of reactive primitives that you can use to build these kinds of applications, and people do, it doesn't fully solve sync. And so last year at the keynote, at the Elixir conference keynote, Jose did a talk on kind of projects that hadn't been done yet, but he wanted to be done. And the main thing he focused on was this concept of Phoenix Sync. And so he sort of dug into a whole bunch of thinking about how you would implement it. He actually then did an implementation, which was very, very cool, and he shared design docs on it. But as we know, building it beyond an initial prototype implementation is hard. And I was lucky enough to be involved in the consultation process around Phoenix Sync. because Jose's involved in our company. And what we both knew was that, like, on reading his design document, he was basically writing our architecture with ElectricSQL. So Electric, we are a sync engine. We're a sync engine for Postgres. We sync data out of Postgres into anywhere you like. I'll just show you a bit about the platform, just so you sort of have a sense of the underlying tech. So as Rob mentioned, obliquely, we have a core primitive called a shape, which is how we manage partial replication. So with this sort of sync for app development, if you've got a big load of data in Postgres, you don't always want to sync all of it into the client. So how do you define the subset of data that you sync into the client? And that's what we use a shape for. It was inspired by both the Prisma API, which has like queries with include trees, but also, of course, Ecto, with like particularly the idea of a preloaded association graph. So you could say, I want project 1, 2, 3, 4, and I want all its issues and comments, and I want their users. And you can sort of get that bag of data that comes under the way in which you want to segment your data model for what loads into the client. And so in the front end, when you build on Electric, you write code like this. You can just bind a shape to your component state, and the state stays up to date whenever your database changes. And it's pretty nice as a development model, and certainly people like the team at Linear and Muse and stuff that have built on this have reported back the same thing, the same with Figma and their live graph kind of thing, is you just eliminate a whole bunch of boilerplate that used to be the main part of software development, because you'd have to build like APIs and all this stuff and serialize data and validate, and it's like, it's just gone, right? You just eliminate out a whole swathe of the stack, and you just go, the data's just there in the component. And then under the hood, to make that happen, what we do is we consume Postgres logical replication. So Electric is like a web service, and it just talks to Postgres over a database URL as a normal application would. And then we filter the replication stream, and we fan it out into shape logs. So there's like a log per shape, and then we fan out the shapes to clients. And we do that with a deliberately simple, old-fashioned HTTP API. So you'd always think with this kind of thing that you build it on WebSockets and sort of binary protocols and stuff. We deliberately don't. We build it on old-fashioned HTTP and long polling, and we build it on just JSON because A, you can just use any standard tooling to then play with it and consume it. You can introspect it in the browser console. You can see it over the wire. But also importantly, it means that we can sync through existing HTTP middleware. And that means we can sync through things like edge functions or Cloudflare workers. You can put stuff like in front of a CDN, behind the CDN. But also, you can sync through whatever like HTTP middleware stack that you already have. And so that means, for example, your web framework. So you can sync data through your web framework, which has a profound impact on then how you can actually build applications for real and how in the real world, and how you can integrate sync into existing applications rather than having to like change the whole way you've written your code to adopt it. There was a better slide transition there, which means your web framework, such as Phoenix. And so the whole intention of our system design is to allow you to do sync with your existing stack. And so what we do is we do the hard problems of message delivery, partial replication, fan out, data delivery at scale, and you can use your existing framework for auth, writes, any kind of stream filtering, arbitrary transformations, et cetera. And I won't go into it in depth, but for example, we've written a differential data flow implementation in TypeScript that just allows you to do very cool arbitrary data transformation in front of Electric. So because it just comes through as an HTTP stream, you could use this library in a Cloudflare worker or a durable object. You can do arbitrary joins, stream transformations, materialization, aggregates, et cetera. So the combination of kind of do whatever you like because it's just HTTP and JSON, but the core sync is resilient is a really nice combination. And as I've just alluded to briefly, there's this other key thing, which is that means we can do the data delivery through existing CDN infrastructure. So one of the real challenges with sync is like, how does it scale? And it's like you have 10 users and it works, and you have 100 users and 1,000 users, and you just often get systems exploding. And there's very hard limits on most kind of real-time systems. Like Superbase real-time is a really cool product, but they do rule execution in the database, and it just massively limits the throughput that you can put in just because of the design of the system. And they sort of have to do that because you have to codify your authentication rules into the database schema because you don't have any other sort of point in the pipeline where you can apply them. Whereas if you actually do this HTTP approach, you can authorize stuff just as you would any other web resource. You don't need to put the rules in the database layer, and it means you can avoid the database or the sync service becoming a bottleneck. And so this is a benchmark of just us running Electric behind a CDN, and it shows us scaling out from 100K to 1 million concurrent real-time users on an 80 gigabit per second ongoing workload with flat latency and flat memory use. So the ability to actually scale out to that number of concurrent clients of a single commodity Postgres, just running a single commodity web service to 1 million concurrent users, and there is no like exponential increase, there's no increase in resource use, right? Because it's kind of old-fashioned, simple HTTP, and you just go through like Cloudflare or Fastly or whichever kind of existing CDN infrastructure. So this is kind of really important to these sort of challenges of how you do sync reliably in production rather than just in demo subs with sort of how we're approaching them. And just to mention it, like there's a lot of insight into how we built the product that came from my co-founder, Carl Matthews, who is the founder at Gatsby. And so he did a lot of kind of data delivery into kind of CDN stuff through that. And so he brought a lot of insight in how we could kind of slim down our product to be much more reliable with kind of design decisions like this. So anyway, long story short, Electric is production-grade sync, and we do these challenges of message delivery, scale-out operational reliability. But importantly, everything that we're doing is open source, it's Apache 2, and it's in Elixir. And so talking to Jose, the question is going, okay, there's a very big alignment in terms of the architecture that he would see as the kind of ideal design for Phoenix Sync, and it sort of overlaps pretty much with what we've built out with Electric. Can we do this? Can we use Electric to implement his vision for Phoenix Sync? And not just as a sort of external service, but actually as having Electric as an application dependency, so just a normal hex library within your Phoenix application. And the answer, unsurprisingly, is yes, we have. And for a second name check, I just want to really say thank you to Gary, who sat in the front row here, because everything that I'm presenting about Phoenix Sync is his work. He wrote all the code, and it's awesome because he's done a fantastic job. So perhaps could we have a round of applause for Gary? You really enjoyed that, right? Yeah. So this is what I'm here to introduce. So we've just published this on Hex. It's on GitHub. It's built on Electric. It's integrated natively into Phoenix. We've worked a lot with Jose and also Chris McCord on looking at the API design and what's the best way of kind of wrapping up this capability to feed into the existing Phoenix APIs and primitives. And basically, it enables real-time sync for Postgres-backed Phoenix applications. If you're looking for it, it's on Hex as Phoenix_sync. So that's enough keynote. Let me dive into the demo. I'm going to jig my screen. Dun, dun, dun. Okay, cool. What I just wanted to do first was just walk you through the APIs that we've kind of looked at. And they're basically summarized here. This is the README for the project. So this is what it does, as I've been saying. It's real-time apps and locally synced data. You can use it to sync into back-end Elixir applications, so like a Phoenix application, any application using Plug or Elixir. You can sync, particularly there's a tight live view integration, so you can sync into live view. So you sort of connect, so live view does the sort of front-end reactivity, but this sort of fills in that kind of missing piece on the back end. And you can use it to sync all the way into front-end applications. So you can sync through Phoenix into front-end web and mobile applications. And it has this API design where there's a big conceptual fit between Ecto queries and shapes. We sort of model shapes on Ecto queries in the first place. Now, we haven't implemented the full expressivity of every SQL feature in shapes yet. We do some queries against Postgres, but then when we're monitoring the ongoing logical replication stream, we have to sort of do the kind of clever query logic and joins and stuff ourselves. So shapes are, at the moment, limited to like Ecto queries with an array of where clauses. So you can filter down tables, and then you can use stuff in front of it to kind of join data up if you need to. And what we're working on as a team is we're working on just adding in the sort of common 80% of things, so joins, include trees, limits, ordering, etc. So that primitive will become more expressive, but one of the limitations of the library right now is whilst it's a very nice API design to basically express the shape definition through an ecto query, you can only use some features of ecto queries just right now with this initial release. And there's 4 key APIs. So the first thing is just there's a generic Elixir client, so it's this Phoenix Sync client. And then to sync into a live view, we integrate with the Phoenix Streams machinery. And then there's 2 more, which I'll come to in a sec, but let me just sort of talk through these. So the first one for low-level usage in Elixir, it basically takes an ecto query and it turns it into an Elixir stream. And then you can do whatever you like with that stream. And you can just use like a schema if you want to like sync all the data in the table, or you can use an ecto query and kind of filter it down. It's sort of up to you. So I mean, just the first thing, just to kind of show that working. So here I've got a couple of terminal windows, if you can see them okay. In the top, I've just got a project with this installed, and I'm going to run this Phoenix Sync client stream function. We've got a schema, which is just like instructions for the demo that I'm about to run, and then I'm just running that through IO_inspect so we can see the output. So if I just run that, it sort of starts with an up-to-date message. This is sort of one of the control messages that comes through our protocol. And then down below, I'm just connected with PSQL to the Postgres database, and I'm just going to insert a sort of harmless demo instruction. And as I insert it, you see it just comes through in Elixir. And so that's the sort of low-level primitive which we're using internal to the library to then wire into other things, and you can build what you like on it. You could route that stuff into PubSub, channels, you name it. You could send out distributed messaging. You've got all the fantastic real-time primitives available in Elixir and Phoenix. And then the next one is then wrapping that up into a tighter live view integration. So this code here is just an example for a simple live view, and what we're doing is we're using this sync stream function to, again, take an ecto query, which here is like the schema name, to do the to-dos, and basically assign that to a to-do stream, which will be available in the live view. And then live view does the cool stuff where you're not like maintaining the whole collection server-side in memory in order to kind of have the collection synced into the client. But the difference between using stream, which is the built-in Phoenix stream function, or sync stream, is that this keeps the query live and up to date. So the API change is minimal, but the power is really quite strong. So like this is a live view in the demo I'm just going to run. As you can see here, for instance, I've got a couple of these sync stream functions. Like if we were using standard live view, it would be that, and you just add sync as a prefix to it, importing the library, and there you go, right? That turns it into this full end-to-end stack where you can just write data into Postgres and it's immediately synced out into all the clients. And so you have this kind of power to build, like live view is pretty cool to build these like reactive applications, but suddenly you have this sort of full end-to-end reactivity where you could have like a side application writing into Postgres and you have like a React dashboard and it's all just kind of live and it just works and there just is no wiring at all. There's no JavaScript, there's no boilerplate, there's no polling the database. So as a development model, it's really pretty compelling. And so that takes us into our first part of the demo. Yeah, I was going to show, by the way, I mean, this is the stream function just in the live view documentation. And so it's basically just to kind of swap out. But so as we said up front, so I hope if you can be on the Wi-Fi, things are going to work better. And also, like real-time demos, you always do things like sort of cursors and moving around and to-do lists and stuff. I'm actually going to show you a linear clone in a sec. But I want to do something more fun, and so I thought I'd do an audio demo. So what I'm going to do is basically to do a first part of this is a sound check. And so I'm going to be basically using this live view integration, write something into the database, it's going to stream out to the clients, and then a hook is going to make you play that music. So it's only going to work as a kind of demo if please, if everyone does it. So please do get your phone out and do this. I'd really, really, really appreciate it. And also, excellent, I see things coming. And also, make sure you're not on mute, and maybe sort of like turn the volume all the way up and then a couple of notches down, and let's see what kind of noise this makes. So I'll just maybe pull that over to the side here, just in case you still need it. And then what I'm going to do is I've got this running on a server, so I'm just going to SSH into it. And then I'm just going to connect to the local database on the server. How are we all doing, by the way? Is everyone up? Could I have a show of hands if you've got it up and running? Ideally, a show of phones. That'd be awesome. Brilliant. Anyone need a moment to still get ready? Mobile will still work. There's just the next part of the demo has much tighter synchronized clock synchronization, which is where the Wi-Fi is going to be good. So it's still going to work, but we'll see. I don't know how synchronized this is going to be. So let's do. Okay.
Press start, right?
Yeah, press start and get the speaker up. Yeah, exactly. Yeah. It's the first time I've done this, so I'm probably going to forget parts of the demo. So let's see how it works. So insert into instructions. And we need a name and a value. No, insert into sounds, sorry. Insert into sounds, name, values, and let's do this one. And so I'm going to write that into the Postgres database, and let's see what happens. Nice. Can we do any louder? Has anyone got any volume? Okay, here we go. It's all coming from over there. There's not much coming from over here. How are you guys doing?
Yeah. It works better if I turn it off silent over.
Yeah, that does help. Yeah. Okay, we're getting there. I like it. Claps are not the only one we can do. We can do this one as well. Good one. So anyway, that's just a silly one and also help me calibrate the volume level. Let's just carry on by just walking through a little bit more of the other two APIs. So the thing about this live view demo is, the thing about the live view integration, it is very, very powerful for what it does, but it is not, in a sense, kind of true local first sync, right? Because it's going through live view. Live view is an online system. And so the sort of difference is then if you're actually syncing into the front-end applications, like web and mobile applications, how do you do that? And so that's the next two APIs. So we have a router macro. So in this example here, it's this sync macro. So just as you would do like get or post in your router, you can expose a shape by using the sync macro. And you use the macro in your router when it's a static shape definition that you can define at compile time. It'd be nice to have like the ability to do a dynamic kind of query definition in the router, but then it just really adds to the compile time. So sort of Jose cut that out sensibly. And then what you have if you want to do something more dynamic where you're using, say, the request parameters or the session, is you can use the sync render function. So like at the end of a controller, you would use like JSON or something to kind of render a response. Here, you can have the request coming into a standard Phoenix controller, and you use this sync render view function, and it just exposes a shape. But it gives you full access to just any arbitrary logic, and you can construct the query using, like, in this case, it's the sort of a parameter of the to-do or the user ID from the session. If I jump back into the application here, what we're going to do in the next step for it is, I was kind of thinking about the demo for the talk, and I was thinking back to that time in Lisbon and how I'd missed basically going to the concert because I ended up having to debug the bug with the transaction ID wraparound. And so I was thinking, again, with this idea of let's do something audio because that's more fun, well, how about actually we all become an orchestra and we fill in that performance? So everybody in the audience here, what I'm going to do is we're going to basically, we're going to set out and kind of turn everybody into an orchestra, and then we're hopefully going to, what we're going to do is we're going to write audio data into the Postgres database. Because what we all develop nowadays is going to be AI applications, I thought it'd be nice to show capabilities of that. And also, we're just using Elixir, so we can do what we like. So I've got, for instance, some code in here which is doing stuff like taking audio data, running it through, turning it into vectors, running it through NX as tensors, and I'm writing it into a PG vector column using the PG vector extension in Postgres, which is often how you would sort of sync like vector data into like a local AI system. And there's a thing about this where like it works with just any Postgres model. There's no restrictions on extensions or anything. They all come out of logical replication, so it all just works. And so this is an example where we have like a data model which is like song, tracks, and chunks, and the chunks are where we're storing these like this sort of vector data. So I'm going to write that into the database. That's going to sync out to the devices. And then once you have the local data on the devices, I'm going to send an instruction, and hopefully we're going to have synchronized playback. So let me just, I'll just show you just maybe a little bit more of the code for that. So one of the things is like, if you look at the front-end application here, like previously, for instance, this is the code for the hook that was just receiving the sound that you were playing. But then I got a little React application in here. And as you can see, I'm using like this use shape. And so I have an application that first just syncs in the shapes, syncs in the tracks. So you're going to be able to choose an instrument based on the tracks. And then I have a couple of screens where, for instance, you then like choose an instrument. And then once you've done that, it kind of syncs the data in for you. Thank you very much. And then this is just exposed using those router primitives that we were looking at. So if I come back to the Phoenix application on the back end and I look at the router, the tracks that we're syncing in, we just want to sync all the tracks. So we're fine to use this kind of static compile time definition in the router. But for the chunks, just kind of partly for demonstration, we have a dynamic one that's defined using a controller. So we're building an ecto query based upon a track ID. So you select your instrument, that provides the track ID, and then we filter the audio data that we send you using this function in the controller. And then that just basically kind of comes across the wire, and there we go. So what I'm going to do for this is, so here, so have you got the application open from before on the same page? Awesome. So if you've got that, that's brilliant. So what I can do is just send an instruction to move to the next part of the demo. In the right folder, that would help. Cool, so that's just like a mixed task, just writing something into the database, as you can see, and hopefully you've now gone to a new screen where you see like a start page. So that should be, let me just pull it up as well. Let's have a look. Yeah, so you should be seeing a screen like this. Does that work? Okay, so now to be an orchestra, what I wanted to do was just arrange the room. So you have the opportunity to select one of these three instruments. And I was thinking, the way you do it is at the back, if you could be the drums. So if you're sort of towards the back, please select the drums. If you're in the middle, please select the bass. And then if you're towards the front, can you be the keys? And so what you do is if you select one of those, so for instance, I'll select the bass and you go through, then you'll come to this screen here where it's basically started subscribing to the data for that instrument. And so then what I'm going to do is I'll just work through it in turn. So actually I'll go from the back forward. So what I'm going to do is I'm going to populate the data. So this is the kind of Elixir NX code into PG vector. So I'll do drums. So that's going to write a whole bunch of data into the database, as we see there. And then hopefully, if you're on the drums, do you see the data come through? Do you get a waveform visualization? Awesome, it's synced. So I didn't know how the conference Wi-Fi would stack up to this, but actually it seems to be OK. So let's do the same. So next one for the bass. Here we go. I'm just going to run the command. Let's again populate the data. And hopefully that syncs through to everyone who selected the bass. Awesome. And then one more. I see it on screen. Populate the keys. Do we have it? Awesome. Now I'm seeing syncing clocks here. Do you guys all see syncing clocks, or do you see ready? Oh, ready's good. In that case, this is the moment. Could we turn off the lights and shut the door? And I think I might just try and bump the volume level as well whilst I'm just waiting a sec. Okay. I quite want my one to go ready. So it'll play too. Let's just give it a sec. I'm doing some time synchronization, and it's a delicate art. It's not really part of the core library. Anyone else still waiting on syncing clocks? No, you're good. Okay. Well, let's just do this then. Here we go. It should start quite quietly. Let's see. Oh, I hear sounds. I don't hear many sounds. Is it coming? Let's see. Whee! It worked. It sounded pretty in time. That was cool. So thank you all so much. Yeah, we can do the lights on again. So what I also wanted with that was basically to give a sense of the kind of quality of experience that you can build with Sync, right? I mean, there's a lot of other stuff. Like, for instance, this is an example of our linear clone where we've like built a kind of fully featured project management app just on top of Electric, and basically everything's just instant and it all just kind of works offline, and it's just everything that you'd kind of expect in terms of things not working with live demos for some reason. But like, you can check all this stuff out on our website. There's sort of proper applications that are all built out on the tech, and there's a whole bunch of production systems that are using it. But in a way, yeah, what I wanted to kind of share with the demo was just like this idea of the quality of experience that you can build when you build on Sync with like locally synced data, as opposed to always having to go over the network. And the moral is that like actually rolling Sync is hard. So if you look at it on a kind of application by application basis, you've had companies like Notion, Linear, et cetera, who've invested millions of dollars into building sync engines to differentiate their products. But actually, it should be technology that's provided by a web framework. Like, this should be sort of something that's provided by infrastructure that you can use. And so that's what we've been trying to build with Electric. We've now built it into Phoenix, and it is now just available to use as another state transfer primitive in Phoenix. So you can use Phoenix to build this kind of next generation of sync-based applications. Thank you.
Is there any questions in the audience? Please. Yeah, you can just stand up.
Does this work? Recording? Hello, I'm John. So you showed the slide that showed that you were scaled, or you were connected to millions of clients. Is there also a cap for certain amounts of data sets that you can send there? Like, let's say I have a data set that would essentially sync 1,000 to 10,000 rows of pretty typical data rows. Would that start lowering my client connection number quite drastically?
I mean, there are a bunch of limitations sort of at all levels of the stack, and there's like a bunch of benchmarks here. There's that sort of top level cloud one, but we have benchmarks for like write throughput. So you have like, how much data can you be consuming from the fire hose from Postgres? And then there's a bunch of different sort of scaling factors around like how many shapes do you have, and how shared are those shapes, and what's the sort of, you know, does data go into all of the shapes, or does data only go into sort of some of the shapes? So there's the sort of compute kind of stage where we're doing all this sort of piping and mapping of the data into the right logs. Once the data's in the logs, I mean, it's literally logs on disk. We read sequentially from disk, and we serve it out without any transformation, just through CDN infrastructure. And so there's no real limitation on like the kind of volume of data that you could send out, apart from maybe like, I don't know, egress limits on, or like network connectivity on an Electric server. But the vast majority of it will be served out of the CDN, and CDNs can just handle a very, very large load. You've then obviously got the bandwidth constraints into, say, syncing onto the user. If you're syncing 100 megabytes cold onto a user's device on patchy mobile, then it's not going to be a good experience. So there's quite a few of these sorts of characteristics, and you know, we've sort of tried to do a whole bunch of stuff where we're sort of, you know, checking regressions, trying to keep kind of stable or linear behavior on all of these sort of thresholds of the sync engine. And it also, so one of the reasons why we've done quite a lot of sort of implementations of like the kind of cleverer partial replication primitives like joins and include trees and things, but you get very different scaling characteristics. And so what we're trying to do is implement those things, but with the same thing. So like you can do joins, but you're not exploding the amount of state that you're having to keep, which will just like slow the system down. So there's a lot of, you know, yeah, there's a whole kind of load of stuff in there, and you kind of need to test stuff on a workload by workload basis. And yes, there are, you know, that sort of read scalability is only one part of the picture.
Hello, that was a fascinating talk. Thank you very much.
Thank you.
By watching this, of course, Electric works with Postgres. Given that Postgres has recently started to expand to new areas such as NoSQL, is that also encompassed by Electric's abilities?
Yeah, any data model, any extension, PostGIS, pgvector, JSON, HStores, it all comes out of logical replication is a first-class feature in Postgres, and it comes out in a binary encoding. And then it's really just like, it comes out as binary out of Postgres, and then like it depends how sort of smart you want your client to be in terms of sort of passing that into useful structures into where you're syncing it. But that's actually very like language or client dependent. And so like, there's quite a lot of sync systems that are more sort of end-to-end and therefore sort of specify the client, and therefore you would have limitations on the data model. Whereas Electric, like, I mean, we have a documentation here which is like writing your own client, and you can write your own client in 2 hours. It's one endpoint with an open API spec and like a little bit of control flow and an offset and a cursor parameter. And so, you know, and then if you want to, you can kind of go, I know my data model, I'll do the sort of hydration into the correct native data structures or something.
So as a small follow-up to that then, would that mean that we could replace Postgres with, say, a dedicated NoSQL database, and we could still theoretically link that into Electric and it should just work like magic?
Yeah, I mean, at the moment, our sort of implementation focus has been like, just do it on Postgres. We know we have there's sort of exactly two things. One is defining the sort of actual architecture as a protocol so that you could have any kind of sources feeding in, and also just us building adapters for other common data systems. So there's nothing to prevent us sort of building that out over time, and you could support MySQL and MongoDB and various things. But we just kind of, you know, we're just doing one thing at a time at the moment, and so doing it on Postgres, not worrying too much about the sort of extensibility there, that can come down the track, and just sort of more sort of making it work for that first. Yeah.
Thank you very much.
And the Bean ecosystem gets stronger. Thank you, James Arthur.
Thanks so much.